Hey, this is Scott. I hope things are going well. We're going to take a look at section 4.4 today in chapter 4 of measurement. Section 4.4 deals with accuracy, precision, error, and measuring instruments. Kind of a catch-all unit here to kind of finish up chapter 4. The one interesting piece, I think, is the difference between precision and accuracy. And if you look at the bottom of page 191, where this unit starts, or this section starts, it has a good visual of the difference between accuracy, precision, and how they relate to each other. When the arrows are way far apart, that's both poor accuracy and poor precision. When they're clustered close together, that's good precision. But if they aren't in the bullseye, that's not good accuracy. And so when you get to Archer 3 and you have all the arrows in and around the bullseye, that's good accuracy and good precision. And that's a pretty good good piece with that too. The first thing it talks about is determining the number of significant digits of a number. And if you look at page 192, there's a great chart there that talks about how to determine the number of significant, oops, I misspelled that, significant digits with it all. Significant digits, there we go. And it's different for whole numbers than it is for decimals. You always start on the leftmost non-zero digit. So non-zero digit is anything 1 through 9. And then you count to the right till you get to the rightmost non-zero digit. And that's kind of the same piece with that. So if you had a number like 2,100, start on the left here, right here, 1, 2. Okay, you have 2 significant digits. Okay, if I had a number like 2,100.3, I would have 5 significant digits because it would be 1, 2, 3, 4, 5. That would be 5 significant digits. If you have a number, excuse me, that has a trailing 0 at the end, 2,100 and let's see, something like this. This is going to have 7 significant digits. 1, 2, 3, 4, 5, 6, 7. That's going to have 7 significant digits because the zeros on the end do matter. Okay, they do matter with zeros in the decimal areas. Okay, it doesn't matter with zeros with whole numbers, but the zeros at the end do matter in the decimal area. So it's not too bad there. You just kind of got to count them as you go across that way. That also leads into the greatest possible error of a measurement. When you go to measure something, your greatest possible error is half of the unit you are measuring to. So let's say you, and this begins on page 192 also here. Let's say you've got a 12-inch ruler here, okay, and it goes by inches, and this is just part of it. So we got 1 inch, 2 inch, 3 inches, 4 inches, 5 inches, 6 inches, and I go to measure something, and I tell you that it's 3 inches in length, okay? Really, it could be anywhere from here to here, really, okay? So I could be off by about a ½ inch with that. And so what I did to figure that out, okay, is knowing this fact now, I can take the measurement that I measured it to, which is to the nearest inch, and divide that by 2. So 1 inch divided by 2 equals 1/2 inch. So that would be my greatest possible error. I could be off by a ½ inch with something like this. And the same thing would be true. Let's say I had a different ruler and I got a measurement measured the same thing and got an answer of 3 3/8 inches. Okay. Well, now you can tell I measured it to the 1/8 of an inch. That's what that tells me there. So if I take 1/8 of an inch and divide it by 2, I get an answer of 1/16 of an inch. So that could be my greatest possible error. Basically, it takes the smallest piece that you have it takes what you have measured it to and divide that by 2. Same thing holds in the metric system too with that. Let's say I measured it to the nearest 1 centimeter. I had an answer of 45 centimeters. Okay, I take that 1 centimeter, divide it by 2, and I get an answer of 0.5 centimeters or 1/2 centimeter. Either way, that's how much I could be off by in my error with some of those things. So that's kind of the piece there. That helps you with find your precision. Excuse me, and your greatest possible error. Your precision is what you have measured it to. Okay, so in this case, my precision here would be to the nearest 1 inch. This here, my precision is to the nearest 1/8 of an inch. This one, my precision is to the nearest 1 centimeter. And then my greatest possible error, I take the precision, what I've measured it to, and divide it by 2. So that's kind of how some of those pieces work that way. Some are difference of measurements or different precisions, and with significant digits. Basically, what you have to do there, and if you look on, I'm going to start a new page here. Insert a new page. If you're looking here on page 194, oopsie, get my pen back too. If you're looking on page 194, it talks about, how do you add or subtract numbers or even multiply and divide numbers with different error accuracy with that. So for example, when you're adding and subtracting numbers, you have to find, first of all, you have to get everything to the same unit. So you have to work in all meters or all inches or whatever. And then when you get done, you have to round it to the least precise measurement. Okay, you have to round it to the least precise measurement. So let's say, I'm going to do an easy example here. Let's say we've got 2 feet and 2.5 feet, and we've got 2.25 feet. Okay, we add all these up. Okay, and I got 2.75 feet. Okay, and now I have to round everything to the least precise measurement, and the least precise one is this one in feet. So I have to round this then to the nearest foot. So my answer would be 3 feet. Okay, feet is my least precise measurement, and so I have to round to the nearest foot. So I have to look over here. 7 is greater than or equal to 5, so I round to 3. So my answer here then is 3 feet. Okay. The same thing is true once you multiply and divide as you're working with that. You have to round it to, except you're going to use significant digits instead of the precision piece with that. So let's say we had, excuse me, we can use our same numbers here. If we take 2 feet, we're going to find the volume of this. There we go. We're going to find the volume of this. So I take 2 feet times 2.5 feet times 2.25 feet. Okay, we're going to find the volume of that. I got to grab my calculator here real quick. So when I multiply 2 times 2.5 times 2.25, I get an answer of 11.25 cubic feet. Now, what it tells me when I'm multiplying and dividing numbers, and I need to get them to a certain set of accuracy, and you have to take them to the one with the number of least number of significant digits. So look at our numbers. This one here has 1 significant digit. 2.5 has 2 significant digits. 2.25 has 3 significant digits. So I would have to round this to 1 significant digit. So I would have just this number out front. So I would have to, this is my significant digit right here. I'm going to make that green, my 1 significant digit. So then I have to look at the number to the right of it. Okay, that's less than or equal to 5. And round it down. And so my answer is going to be 10 cubic feet, or feet cubed would be the volume of that. So it's kind of confusing. but yet it's good to know. Depending on the career you end up in, you might use them a ton that way. The next piece is in this chapter is just working with lines, finding the distance between 2 points on a line, and also finding the midpoint of a line segment. So those are pretty straightforward that way. You know, to find the distance between a pair of points, you just subtract it. Okay, so let's say I had we'll go 5 3/4, and I'm going to subtract from it 2 1/2. Okay, I need to find the distance there. It's just like driving down the road. Okay, if I've gone, you know, I'm at mile marker 2 1/2, and I go to mile marker 5 3/4, how far did I go? So I go to subtract these. I need to have a common denominator here. So, and I need to make an improper fraction. So 4 times 5 is 3, 23/4. And I know this is going to have to be 4 here, so I'm going to move this to fourths right away. So that gives me 2/4, and then I have 4 times 2 is 8, plus 2 is 10/4. I subtract these, 23/4. And then I go ahead and convert this back to, that's not 23/4, is it? Oh, that's 13/4, sorry. Thanks for those of you who are paying attention out there. 13/4. And now I need to go ahead and reduce that down. So 4 goes into 13 3 times, and 1/4. Let's say we're working with miles here, so my answer is 3 1/4 miles. Okay. Now the other thing is, like when I'm driving to Rapid City, I always when I first started driving that way a lot, I would always figure out, okay, so I want to stop halfway through. That's like the midpoint of something like that. Okay. And it's the same thing here if you're working with fractions with all that too. But let's say usually when I go to Rapid, I get off at exit 58, and when I leave Mitchell, I leave at exit 330. And so I want to find the midpoint of those two numbers with that. So what I have to do here is, the first thing I have to do is I have to insert a new page so we have enough room for me to write. Okay. Back to my pen. Okay. So, to back up just a second, because we lost all that there, if you're trying to find the distance between 2 points, you just subtract, okay? And let's use my example that I just talked about right now, too. Okay, I want to find the distance between Rapid City and Mitchell. Okay, and if I go to Rapid City, I exit at mile marker 58, and I go to Mitchell, I leave at mile marker 30, or exit 30. So, I go, let's see, I subtract those two. Doesn't matter if you're using fractions or whole numbers, but I subtract 330 minus 58. And so that'll work over here. 272 miles. Does that seem realistic? Yep. 272 miles. Now, let's say I want to find the midpoint. I need to stop somewhere and get a soda pop halfway through. What you do is you take your 2 points that you have, you add them together, and then you divide by 2. So if I take 330 plus 58, okay, divide by 2. So I add these together, I got 388 divided by 2. Okay, so I divide that out. 2 goes into 388. 1. So this tells me that I need to stop at mile marker 194, or the 194th mile. In this spot here is going to be where I need to stop. I need to stop halfway through. Now, for those who are familiar there with I-90, that's going to be pretty gosh darn close to Murdo. I think Murdo is mile marker 192. So we usually pull in there and get a soda and refresh and get on the road again with all that too. But that's what you do. Now, what does this look like? This is going to kind of lead into something later on with all that. But what does this look like here? What are you actually doing here when you're finding the midpoint of something? Yes, for all of you, those who yelled out, you're finding the average of it, you are correct. Because really, that's what you're doing. You're finding the average of two things. You add them up together, you get two numbers, divide by the number of numbers, 2, and so you find the average there. And that's what you're doing when you're finding the midpoint. Basically, you're finding the average of those two numbers with that. So anyway, that kind of ends up section 4.4. If you're looking for some problems to do to make sure you got a great understanding of what's going on, those are on, whoa, that's not what I wanted. Those are on page 197, and I think it's 1 through 66. Do those, make sure you have a good understanding of what is happening with those numbers, and we will go from there with that. So next piece after this is going to be your review exercises and the chapter test. So good luck on those things, and we will talk to you later. Have a great day. Bye.